My name is Junhyuk Kong, and today I will be talking to you about gas laws. To start off, what are gas laws? As you can guess by the name, gas laws are laws that relate the pressure, volume, and temperature of a gas. It tells us the properties and characteristics of the variables. Volume of gas increases as the pressure decreases, and pressure of gas increases as the temperature increases. Some background information you need to understand before starting. Particles of the three states of matter each are very distinct and different. Solid has fixed volume and shape, liquid has fixed volume and undefined shape, and gas has an undefined volume and shape. Gases are composed of large numbers of molecules that are in constant random motion. At any given temperature, molecules of all gases have the same average kinetic energy. Kinetic energy is the energy a body possesses by virtue of being in a motion. Continuing on, Kelvin temperature scale is a measurement of the average kinetic energy of a substance. At 0 Kelvin, all molecular motion stops. This shows that temperature and speed is proportional. Next, the standard temperature and pressure, also known as STP, is valued at 0 Celsius and 1 atmosphere of pressure. Gas pressure is the force exerted by a gas per unit surface area of an object, and atmospheric pressure is the particles of gas in the atmosphere pushing on objects. At high altitude, there is less air, meaning there is less atmospheric pressure. I will briefly talk to you about units of pressure and unit conversions before getting into the actual gas laws. First, pascals, also known as PA, is the SI unit of pressure. 1000 PA is 1 kPa, or kilopascals. 101.3 kPa is 1 atmosphere of pressure. Atmosphere is shortened to ATM. Another unit of pressure is millimeters of mercury, or mmHg, and it's also called a torr. Now, unit conversions. 1 ATM is equal to 760 torr, which is also equal to 101.3 kPa. Temperature, called Kelvin, when talking about gas laws, are the relationship between temperature and the average kinetic energy. As previously mentioned, 0 Kelvin is the temperature when particles have zero motion. K can be found by adding the value of degrees Celsius to 273.1, meaning that 0 Celsius is equal to 273.1 Kelvin. Below are some examples of conversion between Celsius and Kelvin. Factors affecting the gas pressure. First, particles. Particles and pressure are proportional, meaning that if one increases, the other will increase as well. Temperature, similar to particles, are also proportional to pressure. At last, volume. Volume is inversely proportional to pressure, meaning if one increases, the other will decrease. Now, the actual gas laws. First, I will talk about Dalton's law. Dalton's law states that in mixture of gases, each gas exerts per of the pressure. The equation of total pressure is equal to first pressure plus second pressure plus third pressure, and so on. This law is the most basic and foremost law. An example question is, a certain balloon contains 0.7 atm of nitrogen, 0.15 atm of water vapor, 0.2 atm of oxygen, 0.1 atm of carbon dioxide. What is the total pressure of the gases in the balloon? You are able to find the total pressure by adding all four of the pressure into one, which would get you 1.15 atm. Second, Boyle's law. This law states that pressure and volume are inversely related. The equation is first pressure times first volume is equal to second pressure times second volume. The example question is, if I have 1 liter of hydrogen gas at 5 kPa and I change the volume to 0.5 liters, what will the pressure be? Since we know the value of first volume, first pressure, and second volume, we are able to plug in those values into the equation and solve for the pressure of second pressure, which would get you 10 kPa. Charles's law. This law states that temperature and pressure are directly related. Key part here is that temperature unit always must be in Kelvin. The equation for this law is P1 over T1 is equal to P2 divided by T2. P stands for pressure and T stands for temperature. The example question is, if I have hydrogen gas at the temperature of 25 degrees Celsius with the pressure of 56 kPa, and I change the temperature to 50 Celsius, what will the new pressure be? We know that P1 is 56 and T1 is 298.1 in Kelvin, and the T2 is 323.1. We can find the value of P2 by plugging in the values, which gets you 60.7 kPa. Next, Gay-Lussac's law. This law explains that the temperature and volume are directly related. Similar to the previous questions, the temperature unit must also be in Kelvin. The equation of the law is volume 1 divided by temperature 1 is equal to volume 2 divided by temperature 2. An example question is, if I have 1 liter of hydrogen gas at 25 degrees Celsius and I change the temperature to 50 degrees Celsius, what will the new volume be? Since we know the value of V1, T1, and T2, we can plug in those values similar to the last question and find the volume of V2 as a 1.08. Now, combined gas laws. This law combines the last two previous laws into one, and then meaning that the equation will be P1 times V1 divided by T1 is equal to P2 times V2 divided by T2. Example question using combined gas law is, a 35-liter gas sample is 15 degrees Celsius and a pressure of 96.7 torr expands to a volume of 50 liters. The final pressure of the gas is 80.7 torr. What is the final temperature of the gas in degrees Celsius? Since we know the value of V1, T1, P1, V2, and P2, and we're trying to find T2, we can plug in those values into the equation, which would get us 96.7 times 35 divided by 288.1 on the left side, and 80.7 times 50 divided by T2 on the right side. And then we are able to isolate the T2 in order to find the value, which would get us 343 Kelvin, and then change the Kelvin into Celsius, which then would be 70.4 Celsius. Lastly, the ideal gas law. The ideal gas law is an assumption that gases behave ideally. It explains that the particles and pressures are directly related. Now you might ask, what is an ideal gas law? Or ideal gas, rather. An ideal gas is believed to have like a small sphere, or like a small atom. It does not attract or repel other particles, and collisions are perfectly elastic, meaning no energies are lost during collision. However, in the real world, all real gas particles have volumes, and they all attract and repel each other. Therefore, ideal gases do not exist. The most quote-unquote ideal gas would be helium, as they have small atoms, low mass, and low interaction. The equation part of the gas law. The ideal gas law shows that P1 times V1 divided by T1 times N1 is equal to P2 times V2 divided by T2 times N2 is equal to R. The N stands for moles of particles, and R stands for law constant. P stands for pressure, V for volume, T for temperature. To find the value of R, when pressure is kPa, the value of R would be 8.31. If it's an atm, the value of R would be 0.0821. If it is millimeters of mercury, the value of R would be 62.4. The simplified version of the equation would be P times V equals N times R times T. An example question using the ideal gas law is: a steel container with a volume of 20 liter is filled with nitrogen gas to a pressure of 2 times 10 to the power of 4 kPa at 28 degrees Celsius. First, we will change the value of 28 degrees Celsius to Kelvin, which would become 301.1 Kelvin. And then we know that 20 liters is the volume, and 2 times 10 to the power of 4 is our pressure. Then we can plug in those values into the equation, which should get us 2 times 10 to the power of 4 times 20 is equal to N times 8.31 times 301.1. Then we are able to find the value of N, or the value of mole of gas, as 160 mole of nitrogen gas. Another version of an ideal gas law is bigger case M is equal to lowercase m times R times T over P times V. The bigger case m stands for molar mass and lowercase m stands for the mass. You can find the value of mole, or N, by dividing the mass of the gas by molar mass of the gas. You can also find molar mass or mass using the same equation. An example question for this version of ideal gas law is: what mass of argon gas is contained in a 2 liter at 301 Kelvin and 1.25 atm of pressure? We can plug in those values into the equation, which would be 39.95, as that is the molar mass of argon, is equal to m, the mass, times 0.0821, which is the value of R, and times 301, divided by 1.25 times 2, the pressure and volume. After isolating the m, the value we would get is 4.04 grams of argon. In summary, gas laws are laws that relate the pressure, volume, and temperature of a gas. Gases are composed of large numbers of molecules that are in constant random motion. The standard temperature and pressure, STP, is 0 degrees Celsius and 1 atmosphere of pressure. Particles and temperatures are proportional to pressure. Volume and pressure are disproportional. Gas pressure is the force exerted by a gas per unit surface area of an object. Atmospheric pressure is the particles of gas in the atmosphere pushing on objects. The gas laws covered in this video are Dalton's law, Boyle's law, Gay-Lussac's law, combined gas laws, and the ideal gas law. There is one gas law that is not covered, which is the Avogadro's law. It is very similar to Boyle's law and Gay-Lussac's law. It shows that the volume of gas and mole of the gas is proportional, and the equation is first volume divided by first amount of gas in moles is equal to the second volume divided by the second amount of gas in moles. This wraps my video on gas laws, and thank you.